Good morning everyone. Today I'll be talking to you about wood, which is a major renewable resource. Points that are to be discussed in this topic are wood and what it is all about, and the utilization of wood in paper manufacture industry. We will also tackle about estimates of some recoverable fossil fuels and the efficiency of some energy conversion process. So what is wood? Wood is a hard fibrous material that forms the main substance of the trunk or branches of a tree or shrub. It is also porous and is an organic material. Wood is mainly used for fuel or timber. So as mentioned previously, it is a renewable resource, which means that additional resources can be grown to replace any wood that is cut down. The chemistry of wood. The chemical composition of wood varies from species to species, but it's approximately 50% carbon, 42% oxygen, 6% hydrogen, 1% nitrogen, and 1% other elements like, or mainly, calcium, potassium, sodium, magnesium, iron, and manganese. And these are all percent by weight. Wood also contains sulfur, chlorine, silicon, phosphorus, and other elements in small quantity or trace amounts. Wood is essentially composed of cellulose, hemicelluloses, and lignin. More on this on the next slide. First is cellulose. It is the major chemical component of fiber wall and contributing around 40 to 45% of the wood's dry weight. It is composed of linear chains of D-glucose linked by beta 1,4-glycosidic bonds. Cellulose has a strong tendency to form intra and intermolecular hydrogen bonds by the hydroxyl groups on these linear cellulose chains, which stiffen the straight chain and promote aggregation into a crystalline structure. Hemicelluloses, the second important constituent of wood, are also sugar polymers. Unlike cellulose, which is made only from glucose, hemicelluloses consist of glucose and several other water-soluble sugars produced during photosynthesis. They are composed of shorter molecules than cellulose and, and make up 20 to 35% of the dry weight of wood. There are many varieties of hemicelluloses, and they markedly differ in composition in softwoods and hardwoods. Lastly, lignin is a class of complex organic polymers that form key structural materials in the support tissues of most plants. Lignins are particularly important in the formation of cell walls, especially in wood and bark, because they lend rigidity and do not rot easily. These three components are interwoven, and direct covalent linkages exist between the lignin and the hemicellulose. A major focus of the paper industry is the separation of the lignin from the cellulose, from which paper is made. A major use of wood is in paper manufacture. The widespread use of paper is a mark of an industrialized society. The manufacture of paper is a highly advanced technology. So paper consists essentially of cellulosic fibers tightly pressed together. But how is paper made? Paper is made in two steps. 1. Cellulose fibers are extracted from a variety of sources and converted to pulp. 2. Pulp is combined with water and placed on a paper making machine where it is flattened, dried, and cut into sheets and rolls. Paper machines are comprised of four primary sections: the wet end, wet press section, dryer section, and calendar section. In the wet end, pulp is mixed with water as well as additional fillers and additives and then pumped onto a belt. This belt is typically made of a mesh that encourages all of the fibers to go in one direction. This section of the paper making machine has at least one roller to push the fibers onto the belt to help make sure that the paper grain goes in the right direction. In the wet press section, the pulp moves off the mesh belt onto a felt belt. The pulp moves through a series of high pressure rollers designed to push the liquid into the felt. Once the pulp enters the dryer section, it has started to take the shape of paper. This part of the machine weaves the web of paper through a series of heated rollers. Felt belts are also used in this part of the machine to give the moisture in the paper somewhere to go. The last part of the machine is called the calendar section. It uses rollers mounted opposite of each other to put pressure on the paper and create a smooth finish. The more of these rollers there are, the smoother the paper will be. So wood fibers and particles can be used for making fiberboard, paper-based laminates, which are layers of paper held together by a resin and formed into the desired structures at high temperatures and pressures. It can also be used to make particle board, consisting of wood particles bonded together by a phenol formaldehyde or urea formaldehyde resin. And lastly, non-woven textile substitutes consisting of wood fibers held together by adhesives. Moving on to the energy problem. In October 1973, also known as the Yom Kippur War, Egypt and Syria launched a surprise military campaign against Israel, and the US supplied Israel with arms or weapons. In response to this, the Organization of Arab Petroleum Exporting Countries, or OPEC, consisting of the Arab members of OPEC plus Egypt and Syria, announced an oil embargo against Canada, Japan, Netherlands, United Kingdom, and the United States. The embargo occurred in response to US support for Israel during the Yom Kippur War. By the end of the embargo in March 1974, the price of oil had risen from $3 per barrel to nearly $12 globally. US prices were significantly higher. The embargo caused an oil crisis or shock with many short and long-term effects on global politics and the global economy. The crisis had a major impact on international relations and created a rift with NATO. Some European nations and Japan sought to dissociate themselves from United States foreign policy in the Middle East to avoid being targeted by the boycott. To address this, the Nixon administration began multilateral negotiations with the combatants. By January 18, 1974, US Secretary had negotiated an Israeli troop withdrawal from parts of the Sinai Peninsula, the place where the war was happening. The promise of a negotiated settlement between Israel and Syria was enough to convince Arab oil producers to lift the embargo in March 1974. However, the OPEC members agreed to use their leverage over the world price-setting mechanism for oil to stabilize their incomes by raising world oil prices after the recent failure of negotiations with Western oil companies. So here's a summary of what happened.
Reported by John Chancellor.
Good evening. The Middle East war produced developments all over the world today. The oil-producing countries of the Arab world decided to use their oil as a political weapon. They will reduce oil production by 5% a month until the Israelis withdraw from occupied territories. If the Arab countries keep that pledge, it would reduce their production by almost 50% in 1 year. There were diplomatic maneuvers at the United Nations, in Washington, and in Cairo. And there is a savage and possibly decisive tank battle raging in the Sinai Desert. The decision to cut back on oil production as a weapon against Israel was taken at a meeting in Kuwait, which was attended by the Syrians and the Egyptians as well. Less Arab oil won't hurt the United States much, but it will pose quite severe problems for the Japanese and especially for the...
At present, most of the energy consumed by humans is produced from fossil fuels. By far the greatest recoverable fossil fuel is in the form of coal and lignite. Furthermore, only a small percentage of this energy source has been utilized to date, whereas much of the recoverable petroleum and natural gas has already been consumed. So fossil fuels are made from decomposing plants and animals. These fuels are found in the Earth's crust and contain carbon and hydrogen, which can be burned for energy. Coal, oil, and natural gas are examples of fossil fuels. Coal is a material usually found in sedimentary rock deposits, where rock and dead plant and animal matter are piled up in layers. More than 50% of a piece of coal's weight must be from fossilized plants. Oil is originally found as a solid material between layers of sedimentary rock like shale. This material is heated in order to produce the thick oil that can be used to make gasoline. Natural gas is usually found in pockets above oil deposits. It can also be found in sedimentary rock layers that don't contain oil. Natural gas is primarily made up of methane. According to the National Academies of Sciences, 81% of the total energy use in the United States comes from coal, oil, and natural gas. This is the energy that is used to heat and provide electricity to homes and businesses, and to run cars and factories. Unfortunately, fossil fuels are a non-renewable resource, and waiting millions of years for new coal, oil, and natural gas deposits to form is not a realistic solution. Fossil fuels are also responsible for almost three-fourths of the emissions from human activities in the last 20 years. Mining and drilling contributes to erosion, sinkholes, deforestation, loss of biodiversity, significant water, significant use of water resources, dammed rivers and ponded waters, wastewater disposal issues, acid mine drainage, and contamination of soil, ground, and surface water, all of which can lead to human health issues in local communities. The good news, however, is there are many alternative resources. Geothermal power is electrical power generated from geothermal energy. Hot water is pumped from deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. The steam spins a turbine, which is connected to a generator that produces electricity. Another alternative is hydroelectric energy. It is a form of energy that harnesses the power of water in motion to generate electricity. Wind power is created using a wind turbine, a device that channels the power of the wind to generate electricity. Solar power is also an alternative resource in which the energy from the sun is converted into thermal or electrical energy. Energy conservation is the decision and practice of using less energy. Here are some ways for you to conserve energy or be more energy efficient. Turning off the light when you leave the room, unplugging appliances when they're not in use, walking or cycling instead of driving. You may use energy saving light bulbs or air dry clothes and dishes. As shown in the figure, energy occurs in several forms and must be converted to other forms. The efficiencies of conversion vary over a wide range. Conversion of electrical energy to radiant energy by incandescent light bulbs is very inefficient. Less than 5% of the energy is converted to visible light, and the remainder is wasted as heat. At the other end of the scale, a large electrical generator is around 80% efficient in producing electrical energy from mechanical energy. Wanka rotary engine converts chemical to mechanical energy with an efficiency of about 18%, compared to 25% for a gasoline-powered piston engine and about 37% for a diesel engine. This is why diesel cars are more fuel efficient than gasoline-powered cars or automobiles. A modern coal-fired steam generating power plant converts chemical energy to electrical energy with an overall efficiency of about 40%. One of the most significant energy conversion processes is that of thermal energy to mechanical energy in a heat engine, such as a steam turbine. The Carnot equation states that the percent efficiency is given by a fraction involving the inlet temperature, for example, of steam, T1, and the outlet temperature, T2. These temperatures are expressed in Kelvin. Typically, a steam turbine engine operates with approximately 810 Kelvin inlet temperature and 330 outlet temperature. And after plugging in these into the equation, the theoretical efficiency is around 59%. However, because it is not possible to maintain the incoming steam at the maximum temperature, and because mechanical energy losses occur, overall efficiency of conversion of thermal energy to mechanical energy in a modern steam power plant is approximately 47%. And if we take into account losses from conversion of chemical to thermal energy in the boiler, the total efficiency is about 40%. However, this can be avoided by increasing the peak inlet temperature in heat engines. Substantial advances have been made in energy conversion technology over many decades, and more can be projected for the future. Thank you all for listening, and goodbye.